Hello again. So now I'm very excited about this moment because finally we're going to get to talk about an actual example where we're going to actually talk about finding a probability associated with a normal random variable. Okay, so let's read it together. So suppose that the quantity of coffee David makes is normally distributed with mean 15 ounces and with a standard deviation of 1 ounce. What is the probability that the amount of coffee David makes is between 14 and 16 ounces? Okay, so it might help us in this case to draw our normal curve. And I encourage you to draw normal curves whenever you're going to do a normal problem because it's going to help you develop an intuition of what you're looking for. Okay, and it's always good to label it. Okay, because that's also going to help you to develop intuition, and it's going to help you to get an idea for what you're looking for and if you've completely understood the problem. So I know it's normally distributed, so I'm going to draw my bell curve. Okay, and it says that the mean is 15 ounces. What do we know about the mean with respect to the normal random variable? We know that the mean is dead center, right? So I know that right here in the middle, it'll be 15 ounces, okay? That'll be my mean, okay? I don't know why my drawings are just like so bad today. What else do we know? We know from the problem statement that the quantity of coffee David makes has mean 50 ounces, but it has a standard deviation of 1 ounce. Okay, so let's start making this a little bit more detailed. So if I go one to the left, it's 14. One further to the left, that's 13. One further to the right, that's 12. Okay, so this is my mu minus sigma, the mean minus the standard deviation. This is my mean minus 2 sigma. And this, of course, as you can already imagine, is my mean minus 3 sigma. Similarly, I can add 1. I get 16. That's mu plus sigma. In other words, the mean plus 1 standard deviation. I can add another standard deviation. I get 17 over here. That's the mean plus 2 standard deviations. And then finally, 18. That corresponds to the mean plus 3 standard deviations. Okay? And the question is asking, what is the probability that the amount of coffee David makes is between 14 and 16 ounces? Aha. You know, it's going to be between 14 and 16. So we remember from our discussion of normal random variables that the probability that the normal distribution is going to take a value between a certain boundaries, okay? So here, let's call this random variable x, and it's normal with mean, in this case, 15, standard deviation 1, right? So using this notation, what we're really asking was the probability that that the random variable will take on a value between 14 and 16. Well, what I want, and so in other words, that we know is the area here in between these boundaries, right? Well, because we know the empirical rule, we can see that that exactly corresponds to the boundaries that are 1 sigma away from the middle. In other words, from mu minus sigma to mu plus sigma, that's 68% of the curve, right? Or in other words, 0.68, right? Because of the empirical rule. Okay. So that's the answer to the question. The probability that the amount of coffee that David will create, that quantity lies between 14 and 16, is 0.68, or in other words, 68% of the time that'll happen. Now, I'm going to expand a little bit more. We know that if we were within 2 sigma of the mean, that would occur with a 95%, that would occur 95% of the time, again by the empirical rule. So we could say that the probability from 13 to 17 being the boundaries would be 95%. And of course, you can already extrapolate from 12 to 18 the probability that the amount of quantity David creates at any given time is between 12 and 18 ounces would be 99.7% of the time, or in other words, the probability would be 0.997. Okay, Always remember the probability is between 0 and 1 always, but but you can write it as a percentage if you want. If they're not asking for the probability, but if they're asking for the probability, it's always between 0 and 1. So the empirical tells us that 68% of observations will lie within 1 sigma. That means that the probability of lying within 1 sigma is 0.68. Okay. Anyway, I hope you've enjoyed this example, and I look forward to seeing you again soon. And yes, let's do that.